When you step into a packed elevator, how do you know that steel cable won't suddenly snap? Because engineers don't just guess. They map a material's exact breaking point using fundamental mechanics. The cabin's weight pulls down, and the steel resists. That internal pressure is stress, and the stretching is strain. If you stay in this linear elastic zone, the cable acts exactly like a spring, bouncing perfectly back to its original length. But overload the car, and the steel loses its ability to bounce back. It crosses a threshold called the yield point. Now it enters the plastic zone. Even when the load is completely removed, the cable stays permanently stretched out. And real life is messier. Elevators sway, twist, and grind, creating complex multi-directional forces. To predict exactly when these chaotic forces will cause a break, engineers use failure theories, changing the math depending on whether the material safely bends or suddenly shatters. But because of unpredictable impacts or hidden flaws, they intentionally overbuild the entire system. They apply a factor of safety, setting the maximum allowable stress to just a tiny fraction of the actual failure point. So that elevator cable holds perfectly, because engineers calculated exactly where it would break and designed it to never even come close to that limit.